Okay, Calc, this is 7.2, the section on log functions. In the last video, we talked about exponential functions. So you might have something like, I don't know, for an exponential function, um, you might have 2 to the third power equals 8. Okay. A lot of times I'll write that as like 2 to the x power and x equals 3, which basically means you're plugging 3 in for x, which will give you 2 to the third power equals 8. If I want to make that into a log function, you take and you first need to figure out what the base of your log, it's kind of like the subscript is. The base of the exponential function here is 2. The base of the log is also going to be 2. So that first number kind of stays in the same spot. The second two numbers flip with each other. So the 3 and the 8 is going to be log base 2 of 8 equals 3. And that's what that's going to look like as a log. Okay. So first number stays in the same spot. Second two numbers switch with each other. Since this is the base of the exponential function, this will be the base of the log. Okay. Now the relationship between logs and exponential functions are that they are inverses of each other. Okay. So if you have an exponential function and you're trying to solve it, you would use a log. If you have a log function and you're trying to solve it, you would a lot of times use an exponential function. So we'll be dealing with solving some of those in the next couple sections. But this is just kind of learning the properties of how logs operate. So they have here in part A, they say log base 2 of x. They're wanting you to evaluate that, and they're saying x is 32. I don't know why they write it like this, why they don't just say log base 2 of 32. But anyway, so you have log base 2 of 32, and then we're trying to solve that. Okay, so since they've already used x, I'm going to use y. So I always set it equal to y because we're trying to solve, like, what is log base 2 of 32. So if I rearrange this to an exponential function, so now we're going back the other direction, okay? The 2 would stay in the same spot. This would be 2 to the y power equals 32, which basically means how many times do I have to take 2 times itself to get 32? And you will find that y is 5, okay? So I just called it y because they had already used x up here, but anyway, you're just solving for and trying to figure out what that y value is, okay? Same thing with this one, so if I plug that 1 over 100 in for x, I'll have log base 10 of 1 over 100. Sometimes you'll see it written with parentheses, and that's okay. If I set that equal to y and then switch him to an exponential function, exponential function, I'll use that notation so you can kind of see what I'm doing. This just means 10 to what power will give me 1 over 100, or what will y be in order to get me from 10 to 100 to 1 over 100. Now I know going from 10 to 100, that is to the second power, right? 10 squared is 100, but how do I get 1 over 100? Well, that's going to be the negative second power, right? So 10 to the negative 2 power will be 100, but it will be 1 over 100. That's what that will look like. Okay, so in this case, y is going to be negative 2. Okay, so just kind of remember, if you're going from a whole number to a fraction, he's going to involve a negative inside of his stuff. Okay, so I'm going to go down here to some of these properties, and I'm going to skip the box and just kind of tell you which one of these belongs with each one of those 4. So solve the equation. They say log base 2 of x equals log base 2 of 3. Okay, if I have an equal sign and I have 2 logs on either side, or 1 log on either side, and they both have the same base, I can basically cancel those 2 guys out. So in this case, x would just be equal to 3. Okay, this is going along with number 4, property number 4, which just says that the log base a's can cancel out as long as they're the same base, and then x is equal to y. Whatever's over here is equal to that over there. So in this case, I'd have x equals 3. Okay, now in part B, if we're solving for x, I always just, in this case, this is what they're wanting us to do. They say log base 4 of 4. Since the base of my log and the base of this number are the same, those 2 things are just going to cancel out with each other. Okay, so when they cancel out, though, they don't just make 0. When you cancel things out, it actually simplifies to 1. So this would say 1 is equal to x, or x equals 1. So if these 2 numbers are the same number, then you can cancel those guys out. But when it cancels out, it becomes 1. Okay, it's kind of like if you have 7 divided by 7. That doesn't cancel out to be 0. That actually cancels out to, or reduces to be 1. Okay, so it's kind of that same property there. That's what this one was saying, number 3. So this one kind of goes with number 3, where it says log base a of a, if those two things cancel out, you're just left over with the x. Okay, now the same thing will happen. I'm going to go down to part D. The same thing will happen if I have those two switched around. So this is my exponential function, and the exponent is log base 6. Okay, so this is kind of the weird, funky way of writing it. I have an exponential function, and then the log is stuck in the exponent. So since the base of the exponent and the base of the log are the same number, I can cancel those out, and that would just be 20 left over. Okay, or basically this would be 1 times 20. Okay, is how that would work out, and that's what they're demonstrating with the second half of number 3. So this one kind of goes with number 3 also, but like the second half, it's just writing them in the opposite order. Okay, and this one, simplify the expression. This one goes with number 3 also. Okay, whatever. Log base 5 of 5, since those two numbers are the same, those can cancel out. So this would be like 1 times x, which is just going to be x. So that's the simplification. Here we were just simplifying. So we're ending up with x, we're ending up with 20. Here it was a solve the equation because we actually did have an equal sign. So we're saying x equals 3, x equals 1. So this one went with number 3, I guess, also. Okay. Up here, well, I guess, yeah, 3 and number 2 and number 1 are kind of all the same. Log base a of a, I said that those guys crossed out to be 1. So I guess this is kind of rule number 2, whatever. And then a to the first power is a. So whenever you have those cross out, because the base and the exponent are the same number, if I would rewrite this as an exponential function, okay, this first number would stay in the same spot, those second two numbers would switch. So basically this is like saying a to the first power equals a, is what this log base a of a equals 1 is saying. And then this one right here, I'm going to rewrite this. Let's put some numbers in here. Let's say log base 4 of 1 equals 0. Okay, I could rewrite this as an exponential function, saying 4 to the 0 power equals 1. Okay, so what they're saying with this first property is that if this number here is 1, the answer is always going to be 0, because anything to the 0 power is always equivalent to 1. That's what they're kind of getting at with that first property. Okay, so if 1 is in this spot, the answer is 0, regardless of what this number is right here. So graphs of log functions are going to be the inverses of graphs of exponential functions. So if I kind of think about what my exponential function looked like, he's crossing here at 1. This is what the exponential function would look like. Okay, now because they are inverses of each other, if you kind of remember inverses, that property, this line y equals x, they are, flipped across that line. So if this exponential function lives here, the log function of that is going to be the equivalent, but flipped across the line y equals x. So for an exponential function, he had a horizontal asymptote here. For a log function, he's going to have a vertical asymptote. So this guy's going to like suck in really close to there. So he has a VA, and the equation of this VA is x equals 0, rather than y equals 0 like we had for a log function, or an exponential function. Crossing here at 1, now he's going to cross here at 1 on the x-axis instead of the y-axis. So those are just kind of some properties of logs. On the back side, the shifting them are the same as the shifts for the exponential functions. So I just took this guy and I just kind of copied him, but here's what it would look like with a log function. So this is up 3 units, down 4 units. This is what it would have to be in parentheses. This would be 2 units to the right, because negative means right, positive means left when it's in parentheses. Multiplying by numbers out in front is going to stretch and compress him. Horizontal stretch and compress, remember that you have to use the reciprocal. So if you're stretching by 5, it would actually go in the parentheses as 1/5. If you're compressing by 1/3, it would go in parentheses as the 3. And then negative on the outside is over the x-axis, negative on the inside is over the y-axis. Okay, so then the very last thing that they want to talk about is the natural log. On your calculator, you will have an ln button, and then you'll have a log button. Okay, the log button itself, if you just type in log, there's no base number down here, but that base number is 10 because your calculator will think in log base 10 until you tell it to do something different. Some of you guys' calculator will change base, but until you tell it to do something different, it will think in log base 10. Now, ln is another button, okay? And what ln is just another way of writing log base e, okay? So if you're typing in ln, that's called natural log, and that's just log with base of e, not log base 10, not log base 7, not log base 2, it's log with a base of e. And remember that e number is that 2.71828 blah, blah, blah number, right? That comes from compounding interest, like we learned in section 7.1, okay? So log with base of e, that's what natural log is, okay? Use the calculator to evaluate the given function. They just want you to see if you can figure out how to plug in ln of 2. So ln 2, they want you to do ln of negative 1. They want you to do ln of 1 plus the square root of 2, okay? All right, so we're going to end up with some interesting answers on some of these. If you just type in ln of 2, you're going to get a decimal, and it's going to be 0. Let's go to 69. Okay, now, ln of negative 1, natural log, negative 1. If I type it in, it's going to say domain error, which means that there is no answer to ln of negative 1, and here's why. If I'm looking at x being negative 1, okay, this is what a log function looks like, right? Just this bottom graph right here, okay? A log function will not go any past this vertical asymptote. He's kind of like a square root function. He's trapped by that vertical asymptote here, and he's never going to exist on this side. So if I'm saying, hey, where does he touch negative 1 at on the x-axis? Well, he's not going to because he doesn't go past 0. So that's why we will go to domain error. Anytime you plug in a number that's negative into a log, whether it's ln, whether it's log base 7, log base 10, log base anything, if it's a negative number or 0, you will end up with no solutions or a domain error, okay? Because you cannot evaluate him at 0, that's where his vertical asymptote is, or anything to the left of that, unless he would be like I don't know, let's say ln of x, let's say plus 2, which would mean I'm moving him 2 to the left. So in that case, I could plug a negative 1 in because negative 1 would actually make this a positive 1. Negative 1 plus 2 is positive 1. So if I move him, then I can plug in negative numbers, but just straight ln or logs cannot be negative inside those parentheses. Okay. All right. This one here, I shouldn't end up with a negative when I do this one. 1 plus the square root of 2. And that one is just going to be 0.88. Okay, and that's what he will look like. Okay, so they're just wanting to see if you know how to plug stuff in. All right, this one right here, so I'm just going to go through these properties. The ln of 1 equals 0. Okay, anytime I see an ln, I just make him look like log base e. So I replace the ln with log base e. So this is saying log base e of 1 equals 0. If I change him to be an exponential function, first number stays in the same spot, second two numbers switch. So this is e to the 0 power equals 1, which is true because anything to the 0 power is 1. Okay, same thing here. Ln of e is kind of like saying log base e of e equals 1. And we learned from the front side that if these two numbers are the same number, then they just cancel out to be 1 because e to the first power equals e. Okay. I think like John Baylor does like the whole like circle thing, something like that. So you start with this first number to the first power equals e, and you make the circle come back around, whatever. So if that helps you, great. Ln of e to the x equals x. Ln and e cancel each other out because this would say log base e of e to the x power equals x. Those two are going to cancel with each other, so you're just left with x when you simplify. Same thing with e to the ln. Those are going to cancel each other out because this is e to the log base e. So you're just going to be left with x. And then same thing as what we had on the front side. If we have an ln on both sides, we can cancel those out and just say that this part is equivalent to that part. So x would be equal to y. Okay, so they're going to have us simplify some stuff down here. Part A, they say ln of 1 over e. Okay, now I'm going to change this a little bit, and I'm going to change 1 over e to be e to the negative first power, kind of like we would do with derivatives. If I move him to the top, he would just become e to the negative 1. Like 1 over x is x to the negative 1, right? But then ln and e will cancel with each other because ln is log base e. So if it helps you to write it out, you can write it out as that. Log base e and e are going to cancel, so negative 1 is just my answer. Okay, so that's simplifying this. Okay, B, I have 2 ln e. Okay, if you need to write ln as log base e, basically I have log base e of e and then a 2 in front. Log base e and e are going to cancel, and when they cancel, they don't make 0. It makes 1. So this is like 2 times 1 or just 2. Okay. Last one, e to the power of ln. Those are going to cancel with each other. And if you need to write it out, you sure can. This would be like saying e to the log base e of x plus 1. So those are going to cancel out. So that will simplify to just x plus 1. Okay. So this should all be mostly review. I think we either did this in algebra or I know we did it in trig. So for the majority of you, you guys have seen this stuff before, and this is going to be kind of a boring section for you. But it's good to review. So yeah, just these are all properties of exponential functions and log functions. Okay.